Now that we have discussed the key components of our serverless application, let's take a closer look at how they interact in this architecture. This diagram helps us understand the flow from the user's browser to the backend services. When the user opens their browser and navigates to our web app, the first request is sent to Amazon S3. S3 is where our static assets like the React app files, including HTML, CSS, and JavaScript, are stored. S3 then serves the front-end React app back to the browser, allowing the user to interact with the app. At this point, the user sees the app loaded in their browser, but no data interaction has occurred yet. This is just a static front-end. Once the app is loaded, the user might need to log in or sign up. This is where AWS Cognito comes in. The React app sends authentication requests to Cognito, which handles user authentication, sign up, logging in, and managing sessions. Cognito securely authenticates the user and provides tokens, which are passed back to the React app. These tokens are crucial for securing further requests to our backend services. Once the user is authenticated, they can start interacting with the backend. For example, the React app might send a request to create or retrieve a to-do item. These requests are sent to API Gateway, which acts as a front door to our backend. API Gateway forwards the requests to AWS Lambda, where our backend logic is executed. The Lambda function processes the request, whether it's adding a to-do item, retrieving a list, or deleting an item. Behind the scenes, Lambda interacts with DynamoDB. DynamoDB is where all the data is stored. Lambda either writes new to-do items into the DynamoDB table or retrieves the data to send back to the React app. All of these services, S3, Cognito, API Gateway, Lambda, and DynamoDB, are defined and managed using infrastructure as code. We use AWS CDK to write the infrastructure in code, which generates CloudFormation templates that automate the deployment of our architecture. This makes it easy to scale and maintain the entire system. Now that you have a clear understanding of how different AWS components like S3 or API Gateway or Cognito, Lambda, DynamoDB, how all interact together in our serverless architecture, let's dive into the code and build the backend first using the AWS CDK. If you would like to follow along or check out the full source code for this project, please use the link in the description. It's the GitHub repo that contains all the code. It contains all the code after completing the whole application. Please feel free to clone the repo and take a closer look at the code as we build the backend step by step. To create the infrastructure for our project, of course, I am using CDK. So we need to install the CDK CLI first so that we can use it to create the project and deploy and do all the CDK command lines. To build the infrastructure using CDK, we need to install the CDK CLI first. That is the command that we are going to use to deploy or create a new project or destroy the deployed architecture. All CDK commands are run through CDK CLI. So let's first install it. If you have it already, you don't need to install it, but I will install it in case you need to follow along. I'm using macOS. If I'm installing the command like that, it will show permission error, so I need to use the sudo command. So now, because I entered my password already, it's installed. Once you have CDK installed, we can initialize the application by running this command. The command to initialize the application is cdk init app --language TypeScript. In our demo, I'm using TypeScript as the main language, but CDK, of course, support multiple other languages like C# or Java or Go. Let's run the command. After the init command runs successfully, let's have a closer look at the structure of our project. The CDK command will create an initial project with bin, lib, and test and other supporting files as well. So bin folder is the main folder that contains the entry point for our CDK app. This is where you define the main stack and will deploy all of your resources that's included in this stack. Here is an example of the initial empty stack that was created for us by the CDK command line. The second folder is the lib. The lib folder contains all the components that inside our app, all the stacks that inside our app. As you can see, each stack created in the lib folder should be included in the app folder here. Sorry, in the bin folder here. As you can see, each stack created in the lib folder should be included in the CDK app in the bin folder. After you cover the foundation folder structure that was created for us by the CDK command line, let's build our application step by step. The approach that I'm going to follow in building this infrastructure is from the back end to the front end. I will start first by creating the very last component, the deep inside the back end, which is the database. We are using DynamoDB in our case here. So let's start first by clearing these comments. And here is our DynamoDB table that we are going to use for our to-do application. We need to import the DynamoDB from the AWS CDK library, and it's internally have everything we need to create the DynamoDB table. As you can see, we need only the ID as the partition key, and all other properties we need to define in the time of the infrastructure. It will be created dynamically when we store the to-do items. The next component is the Lambda function. The Lambda function is a serverless component that we can write logic inside it using multiple programming languages. In our case, we are going to use JavaScript, and this JavaScript code will interact with the DynamoDB table to create the to-do items and to retrieve or delete whatever we are going to do with the code. So let's first create a new folder in the root, not here, and call it Lambda. Please make sure to follow along the exact structure of folders I'm using here, because when we start deploying, it will refer to this folder structure to build the assets of the Lambda functions, for example, and later to build the assets for the S3 bucket for our React app when we do that. So now we've created the Lambda function. Let's create a handler file. We don't need to go actually in all the logic here. You can check the GitHub repo, but I need to highlight that first, because the type of our API gateway, we need to handle the course here on the JavaScript, the Lambda function level, and the HTTP method will be part of the event object. So for each HTTP method, we have the appropriate logic that's going to handle that method. So we have post, get, put, and delete. And options, we need options without any authentication that will be handled on the API get level. Let's save the handler logic and start building the Lambda function from the CDK repo. So now let's import first the Lambda library from CDK, and building the Lambda functions is as simple as we build the DynamoDB. All we need to know is to refer the assets folder and build it. So here is the Lambda function. So if you refer to the architecture we covered at the beginning of our video, we have DynamoDB table, we have the Lambda function, and at front of them we have the API gateway. One more thing before moving to the API gateway, the way we give the Lambda function permission to access the DynamoDB table is built in CDK in a very smart way. So all we need to do is to access the table that was just created and grant read and write permission to the Lambda function. Now let's build the API gateway that will route requests coming from the front end to the appropriate Lambda function as we follow. Now let's create the API gateway that without all requests coming from the React app to the appropriate Lambda function. Here's the code for creating the API gateway. Of course, we need to import the API gateway library. So it's here. API gateway by itself wouldn't do anything. We need to integrate it with the Lambda function so that all requests coming to API gateway will be routed to this Lambda function. First, we need to create an object called Lambda integration, which is a way to define an integration entity between the API gateway and the Lambda function. So here is how we define this integration. And then later, for all HTTP methods, we need to connect this API integration to our API gateway. What's to-do resource options? Let's cover this later. Just ignore it for now, because it's more into how we authenticate the requests. What we need to focus on for this line at this stage is the methods that we are going to route to our Lambda functions. So we are going to route all methods in post, put, delete, get to the Lambda, the same Lambda. We might integrate it differently using other Lambda functions, but in our case, we use one Lambda function to handle all the requests. Options here is also handled by the Lambda function, but without the to-do resource options. Now, at this stage, let's assume that we already covered the Lambda function, the API gateway, the DynamoDB table, but we need to secure these API calls, because without securing them, anyone could call these APIs and do post, put, delete on our to-do list. So let's define the Cognito user pool and the client. We need to define it here actually. Ideally, it will be the first component to define, but I prefer to make it last component here so that we can understand how it's all integrated together. So let's import the library for the Cognito. So what's happening here? We create the user pool, which is the main component of Cognito, and we allow the email as the alias in our case, which is the username. And we allow also the self sign up so the user can register themselves. And we create a client, which is the main integration point for our app. And we allow the user password authentication, so users can authenticate by username and password. It's out of our scope to cover everything about Cognito and other components, but this is enough for our serverless full stack app for now. To integrate Cognito to our API gateway, we need to create two objects. One is the authorizer, that's authorize our API gateway and our Cognito to handle user authentication for the API gateway. And the other one is the options. This is essential when defining the integration between our API gateway and Lambda function. So that mention what type of authentication we are going to use for each of them. As you can see, for options here, we don't need authentication at all. So when React app do post request, they do options first, and options does not need to be authenticated, but the post request itself will be authenticated. Now we have already built all components essential for our backend. So let's save. So to understand what's going to happen when you run the CDK deploy, we have a command called CDK dev, and this should show us the number of components that are going to be deployed and the properties of them, so that if you want to review and make sure that's not something that you don't intend to do, we're going to be deployed. So for our case, let's straight away deploy. Of course, we need to confirm that we understand all the things that's going to happen for us. Why did we deploy the back end first before building the front end? Because we are going to need the API gateway URL and the Cognito client ID in our front end application. The API gateway endpoint will be logged here in the console, but to get the client ID, you need to open your AWS console and copy it from Cognito user pool client. After we have taken a note from the console log for the API gateway URL that we are going to use in our front end, let's now jump to the AWS console so that we can see the structure of the user pool. There is how here is our user pool, and inside the user pool, like multiple properties and configurations that we did not touch or did not use. And what we are interested in is the integration. So app integration, here we have the client, and here is the client ID that we need to copy so that we can use it later in our front end. So let's copy this one and take a note of it. Now, after we have copied this client ID. Let's go back to our Visual Studio Code and build the front end so that we can test our application working from end to end. Now let's create our front end using React. And to create a React application, I'm going to use the default create React app command line, and I'm going to call this app my app. So let's write this command. If you are following my code exactly, you need to name it my app, because I'm going to use this name in defining the S3 website here. After create React app command line created the basic React app for us, here is the folder structure below my app folder, and all the files that we are going to touch are in the source folder. First, let's build the components that's responsible for the authentication. There are two main components that we are going to use for authentication: the sign in and the sign up. Sign in first. Let's create a new folder called. Let's create a new file called signin.js, and these are the details of that file. The exact code in React here is out of scope of this project, but what we need to highlight here is the client ID and region that we are going to replace by the values from our created backend app, and the usage of Cognito Identity Provider SDK library. Let's minimize this a bit so that we can see the file better. In some cases, we are going to use third-party libraries or AWS libraries to create the front end. Something like Amplify will cover the authentication and other aspect as well for us. But for our demo here, I'm using the SDK as it is, so no need to use any other libraries. This SDK gives us some basic functionality or even advanced functionality for security. In our case here, for example, to sign in, we have this authentication command that we are going to send and mention the flow and the client ID and all other parameters like user and password. So that these are the basic things that we need to cover in this file. Let's build the other sign up file as well. The GitHub repo code has everything we need. So my main goal here is to mention the reason behind each component and each line of code. Let's build the sign up component, and here it is. We have two functionalities here that we use the SDK for. First one is the sign up itself, the command called sign up command, and the sign up confirm, because after you sign up, we will see when we run the app, but after you sign up, you need to confirm your authentication, your email address, by writing the verification code that AWS Cognito will send to your email. Now we created the sign up. Let's create the to-do list app itself. I'm going to name it the to-do list. Let's create the JS file, to-do list.js. Let's go through the code of the to-do list page one by one. So first bit is the loading the to-do list. We need to replace this line with our API gateway URL, but basically this will make a GET request to our API, and this bearer token we will get when we load this component by the sign in. Let's go to the sign in to see how this authentication token will be returned. When we create this authentication command and send it to the AWS Cognito using the SDK, the token will be part of the response, and when we authenticate, the caller of this component should use the token and set it in memory, and using in the to-do list app as a bearer token, which will be used in the get and post requests and the delete request as well. The last bit we need to modify in the React app is the main app.js file that will integrate all these components together. As you can see in React app, we have the sign up, sign in, and the to-do list, and it's all integrated together. So when you authenticate, you don't need to actually sign in again, or when you are not authenticated, you can either sign in or sign up, but all integrated together and using the client ID that we need to replace here and the region, and the API gateway URL as well we will replace in this file. Let's replace these values from our deployed backend components and deploy this front end by creating the S3 website on the CDK. Let's first replace these values. We need to replace the client ID in both the sign in and sign up, and the region. The region I actually used in this setup is AB Southeast 2, and sign in AB Southeast 2. For the to-do list app, let's replace with the API gateway URL. So the API gateway URL is already in our console log. Let's copy it from here. We need to replace the URL until they put it here as well. Before we jump back to the CDK code and build the S3 website, we need first to build the front-end application, and we need to make sure that we import all the libraries that we have used in our code. The main library we need to install here is the SDKs that we have used for authentication. So let's run npm install the AWS-SDK client Cognito identity provider. Let's run npm run build. This line will make sure that the website has been built for us, and the main folder that we are going to deploy to S3 is the output of this command, which is in everything in this build folder. Let's jump back to the CDK code and build the S3 website. What we need to do actually for the S3 website or for our front end is basically two things. First thing is building the S3 bucket itself, which is the core component for S3. We need, of course, to import the S3 library, and after we import the S3 library and use it to create the bucket, let's create the deployment on this S3 bucket. For the deployment, we need to import the deploy library as well. So this library is responsible for adding anything to an S3 bucket. We don't need this line. And let's save this file and make sure that we did not introduce any syntax error or anything that's not going to work. We need to make sure that we run the command from the folder of SDK, because for example, when we run it here in the React app, it will show this error. So let's change directory to the root folder of our app and run CDK thins. To grab the S3 URL quickly, I recommend adding one more component to our CDK, which is the output component. It's basically a component that will show us what is the URL of our website. So let's check our code again and deploy. Now the CDK deployment has finished. So let's copy this URL and check it in the browser to see how our website would work with authentication and API gateway and everything. That's how the website will look like when we open it in our browser. So let's first sign up. We need to use an email. I will write my email here. Copy this email. I'm going to use email and username with the same value, and the password, anything. After you sign up, the confirmation code will be sent to your email. So we need to use it to confirm the sign up here. So sign up has been confirmed now. Let's start add a to-do item. So test, it's working. As you can see, you have created everything in one CDK project. You can create multiple CDK stacks in one project or multiple projects in your solution. But for the scope of this video, we have one CDK project that covers everything, and it's a full stack serverless application. So you don't need to worry about the servers or the infrastructure behind the scene. It will be scaled up, scaled down for you by AWS based on the traffic that's going to reach your website.